This is the question from College Board from the quizzes that they post for you to use to study. So the problem says one end of a string is secured to a ceiling of a classroom and the other end of the string is attached to a sphere of mass 0.2 kilogram so that a pendulum is established. The sphere is raised at an angle of 15 degrees above the sphere's equilibrium position and then released from rest so that the pendulum oscillates. As shown in the figure, location 1 is shown in the figure. A graph of the pendulum's horizontal position as function of time is shown on the graph. The dot below represents, so there is a dot below, right there. The dot below represents the sphere at location 2. So you see location, there is location 2 right here. Draw the free body diagram and label all the forces exerted on the sphere and draw relative length of all the vectors to reflect the relative magnitudes of the forces. Calculate the maximum kinetic energy of the sphere as it oscillates. And then the last part, they say the sphere is released to a new angle above the sphere. Let's come back to this part later. So what we have right now is till B. Actually, we need the dot. So here's the dot. And if I need to show the forces here, when they say make sure that draw the relative lengths of all vectors to reflect the relative magnitudes of all forces, they mean in equilibrium you should now show the tension force this much and mg that much. So if you want to show that this is in equilibrium, you have, or the system is in equilibrium, you have to make sure that your forces equal to each other to be in equilibrium. So that would be the part A. Calculate the maximum kinetic energy of the sphere as it oscillates. If I go back here, I can see that my potential energy at point 1 is going to go to the kinetic energy at point 2. So my potential energy at point, and this is H. This is H. And I'm going to call this one L, and here is an angle. So this part is L sine theta, and this part is L cosine theta. So this one is L cosine, this is L sine. So your H is equal to, and this full length right here is L. So equals to L minus L cosine theta, and equals to L 1 minus cosine theta. And I do not know what L is equal to, but they gave me some information over here on the graph that I can look at. They say horizontal position. So the ball or the mass that they hang here is misplaced this position and this horizontal position. And the maximum horizontal position looks like it's going to be, this is point 1, point 2, this is point 3, so point 25. So your X, so your this part, L sine theta, L sine theta is equal to 0.25 of a meter, and you know what sine is equal to, so L is equal to 0.25 divided by sine, and the angle is 15, so So L is equal to 0.97, or I'm gonna round it till 1 meter. So your L is 1 meter, and other information that is given, mass is 0.2 kilogram, angle 15, and I know now that L is equal to 1 meter. Is also given. So if I go back and see what they asked me for next question, calculate the maximum kinetic energy of the sphere, I'm going to say the potential energy, so for B part, the potential energy at 1, gravitational potential energy, is going to go to the kinetic energy at 2. So I have mg, and instead of h, I have L 1 minus cosine theta is equal to 1/2 mv squared, and that is at 0.2, velocity at 0.2. So two masses can be cancelled, and I have maximum kinetic energy. Actually, I could find the velocity. That's probably what they're going to be asking me. I don't need to find actually even this part, but from here, yes, I could find the velocity. Let's see if we will need the velocity. They only ask you to find the kinetic energy, but your kinetic energy is equal to the initial potential energy. So I can say my kinetic energy at 2 is equal to potential energy at 1, which is mass. Was it 0.2 kilogram? Yes, 0.2 kilogram. G. H is 1. And then I have 1 minus cosine theta, which is 15. And that is equal to 0.068 joules. So that's the answer for this part, 0.068 joules. And then the next part, they say the sphere is raised to a new angle above the sphere's equilibrium position that is less than the angle described for part A. The sphere is released from rest so that the pendulum oscillates. Explain how the motion of the sphere changes if at all, based on the appropriate evidence. So the time, let me do this in different colors. So for C part, the time of the oscillation is equal to 2 pi L over G. The length did not change, so the period is going to stay the same. That means you still will have the same time it takes to travel for one wave. So the time is going to be the same. It's going to be the same. So the period was 2 seconds. Looks like here from the graph, it's 2 seconds. And it's going to stay at 2 seconds. So the period is going to be the same. And but velocity is not going to be the same. So your kinetic energy is going to be decreasing, because if you displace it at a smaller angle, then your h is going to be smaller. So your kinetic energy is going to be smaller, but the force is going to be, restoring force is going to be smaller as well. But it doesn't affect the period. So the period is going to stay the same. The maximum velocity at point, we didn't have to find the velocity, they didn't ask here, but the maximum velocity is going to be smaller, but the time is going to take the same to reach the maximum velocity. And that is it for this question. And so that was question from College Board that they posted. I'm not sure if it's from one of the previous AP exam questions or not, but that's one of the study guide questions that they have on College Board.